So today we will be, knowing some fundamentals of Python and Shell script because in last few classes we understand how distributed computing and distributed storage techniques work with Hadoop and Apache Spark, and then we understand how to configure a small cluster uh, and what are the ways we have to, configure even a big cluster. So it's almost like similar type of configurations is there. Uh, but to work with distributed computing and storage data in an automated fashions, so we need to understand, as our core language is Python. So we'll be going through some basic Python understanding, and also we'll work with Unix shell scripting. So these are two scripting languages, and as in the coming classes we'll be doing some more exercise. So I think if you are already familiar with, I understand many of you familiar with Python and shell scripting. So I hope, you can do some hands-on also while I am taking the session. But for the new ones, I would like you to understand and see what I am doing and what the explanation I am giving while I am running commands, right? So, so let's, go through. So mostly it will be a practical session. So in last class, just to recap, we designed one small Spark cluster, and we see how to configure that. Some basic administration, how to configure Spark cluster. So I hope, many of you tried to configure Spark cluster, and I had received some of the clarifications in my email, also some personal email. So I will get back to you. Thanks for, giving a try. So you would face some problem. That's, that's a common thing. But whenever you are stuck, try to, understand and follow the steps, whether you are missing some steps, or take help from your friends and Googles, because whenever you are trying to set up cluster, as many times you might have problem in different ways. So you need to slowly pick up things, how you can solve problems by yourself, most of the case gradually. So today it's not related to truly big data technologies. It's the core things that we are trying to learn today, and we will be extensively using this Python and shell scripting to solve problems that generally in industry level it will be beneficiary for you guys. So the today's agenda is to just have a brief introduction of Python and some practical sessions of Python. So we are all mostly from the engineering backgrounds. So in our engineering degree, what we try to understand or learn, that how to learn new things, right? So it's not that we always need to learn any new language or technologies from training. So we have to be prepared in such a way that tomorrow also, if there is a new programming language or technology comes, we have to read the documentation and start using them. So, but still, as we have very less time in our hands, so I will be giving some demonstration and basics of Python and shell scripting, so that in the next class or the the coming after class, so you can do some hands-on by yourself and quickly pick up Python shell scripting if you're not, familiar before. And then, we'll see, if we need any external Python packages, how we should be able to install them. And introduction to Unix or Linux operating system, and what is actually shell, and do some shell scripting with a Linux machine. And we can also see how we can schedule one of our Python script an Unix cron job so that it can automatically trigger in certain amount of time in a scheduled manner and do our job. So let's start with Python firstly. So Python is high level language. So for just the theory section, maybe I will go very fast, but in the practical I will try to be a bit concentrated way so that we understand the critical portion of any programming, so that we can implement our logics into code. So Python is high level language like Java and others language. So, and it's interpreted and interactive. Whenever we are running Python, it's not like C or Java that the class files or binary files are generated, which will be actually running on the system. So it is interpreted based and interactive. If you want to run it in an interactive mode, that also will work. And it supports both object oriented and functional. So if you write code without class, it will work. If you write code with class, it also works. So it supports both. So actually, in dealing with a lot of data and big data, machine learning, and artificial intelligence, we won't require, most of the case, object-oriented concept. So it's mostly on functional programming. So initially, it was created by Guidogan, and it's like a Perl, right? Perl is also one kind of scripting language. Python source code is also available under GNU General Public License. And Python is not named after NAC. It's basically a family, TV show, popular TV show in early 1990, in 80s, Monty Python's Flying Circle. From there, the name has been selected. The first release was, on 1994, and one of the most Python stable release, 2.7. Even in CentOS 7 also it is in build. And it has some improvement on the garbage collection and Unicode. And then the Python release 3, especially 3.5.2 on December 2008. So we'll be using, as we are using our Windows machine to do some exercise. So we'll be using 3.5.2 probably in our session. But you remember, right? We installed 3.4 while interacting with Spark. So features of Python, it's one of the languages which can be learned easily, easy to maintain, and it's a readable code compared to any other language. It supports interactive mode, and that's one of the beauty. So it reduces your compile time, and your learning can be very faster. And in some cases, it also gives you some debugging features using the interactive mode. It's portable, meaning it can be run in any platform. There are many packages and libraries, and now it is very popular language for data science. So it supports automatic garbage collection. So it's not that you need to write codes to collect your garbages or memories which are not being used. It's being done automatically. and it can be integrated with any other languages. Just a brief difference between Python 2 and Python 3. So whenever you install, you start writing, let's say, code on Python in a basic CentOS 7 or Linux system, you will be logging into the Python 2.7. So mistakenly, if you started working with Python 2 and you actually work on Python 3, so there are some fundamental changes. So one of the changes, the print function. So in the print function under Python 2, its brackets are optional, but in Python 3, it's made, it's mandatory. And for Python 2, to make a string as Unicode, you have to use U, but in Python 3, it's by default. And one of the changes, the division of integers is always integer. If you divide with 7/2, the output will be 3 in Python 2, but in Python 3, it's automatically give you 3.5. But in parallel, there is, one options in Python 3. If you want to achieve the same result like Python 2, so you have to do 7 /2, then you will get 3. So if you need to take some inputs from users in the consoles while the program is running, so in Python 2 we used to raw underscore input, but it's not available in Python 3. Generally we use input, but input in Python 2 it's take or it serve different purpose. In Python 3, it will expect some inputs from user. So there are some utilities, some conversion utilities, because there are minor changes in Python 3. And whenever you are printing a line, so if you put one comma after that, so this print line will not produce one extra new line for you. But in the Python 3, if you want to remove a new line after printing one statement, then you need to put and equal to double quoted, then it will print a line, but it will not give an entire or new line after printing the line. So these are the high-level differences. Whenever you are interacting to different Python versions, it might be helpful for you to mind, in which environment you are working. So you can, I think you already downloaded Python in your virtual Linux box. But if you want to practice Python in your host machine, you can use this URL to download the Windows, or you can use our given Python 3.5.x and install the binaries. And for Windows, if you start installing, it will ask you to add the Python directories into the path variable of Windows. So you should give yes, so that you can avoid this step setting up at Windows. If you haven't selected that, then you can go from My Computer Properties, Advanced System Setting, and Environmental Variable. So you can edit path and add the installation location, Python installation location in Python path, so that whenever you open your command line window and you type Python, it can understand from where it would be running the Python. So it's just setting up your environmental variables so that it can locate your Python binaries. But if you install, you start installing, it will ask you to select or add that including in your existing path, then this step is optional. And so, if you want to run interactive mode, just press Python and you will be enter into an interactive mode. If you write 2 plus 3, it will give you, output, right? It does not matter whether you write a main function or class. So it's just simply work like an interactive shell. And if you build some Python script, let's say test.py, and it has a lot of, let's say libraries related within it or lines. So you want to run it. So just put Python and test.py, it will start running. And while developing Python, so definitely we use an IDE. So we'll be using PyCharm, and PyCharm has two editions. One is Enterprise, and another is Community Edition. So for the students or non-commercial purpose, you can use always the Community Edition. And the Enterprise, you will have some more benefits. So today, we'll be using PyCharm in our lab. So just before going to Unix shell script, let us just have a look. So I opened one project. So when you install the PyCharm, so you can create your own project. You can name it, and so it will create one virtual environment. So let's say in your Windows machine, there can be 2 or 3 types of Python version installed. So in your virtual environment, you can select, which Python version you want to add as an interpreter. So that in your whole work, so your work has been related with this specific version, and whatever package you will be installing, it will be related to this version. So you can avoid version conflicts and all. So this is about virtual environment. So let's say, so the way, we write the main function like this. If the name equal to main, then we can start writing the main functions. And to understand a language, so we'll be understanding the basics Python structure. What are the variables available and data types supported, and how we can build if else or else if, and how we can run while or for loops, so that we can build our codes based on our logics, and how we need to define functions, normal functions, lambda functions, and how to interact with some libraries that we need to install and that is not coming by default with Python packages, and some of the ways how we can do some string operations. And yeah, let's see. So I will be adding some portion by portion. I will be progressing. So let's say if main, this is our main functions, and in Python script you can mention your arguments. So if you need to access your arguments, that you see, as we are using Python 3, so we have to keep this brackets as mandatory, which was optional in Python 2. So if you need to access the arguments of the Python script, we have to access sys.argv. This is an arrow of arguments. So we can test how many arguments has been passed, and we can also see the details arguments by converting it to string. And we can also print a specific argument. So if I run this specific one, and if you need to mention, because we are using the ID, if you need to mention the arguments parameter, see, I have given a parameter 100 here. So if I now need to run this one, So it's saying that I have given 2 arguments, and the first argument is itself the Python script, and the second argument is whatever we have provided, 100. And then we can also get the or access the second argument using an array index, right? So this is the way, I mean, we can define our Python script parameter, which generally we would need in many cases. So you can push parameter while running Python scripts. And so now if we move to some kind of string operations, so let us move our exit code to somewhere here. So this one is just, I mean, taking when we are starting our program. So I have to import one time package. It is installed by default with Python. So you just need to import. So we are getting the start time, and at the end of the session, I mean, we'll be taking the similar, and we can I mean, evaluate how much time our program takes. So this can be beneficial. I mean, whenever in our last class we'll be processing some files in our running program in a traditional method, and we'll be running similar program in our Spark SDFS, and see, I mean, how the distributed computing is giving us result in a faster way. So in that case, I mean, we will be requiring these time functions. So let's move to the, let's say in a string, I mean, you have a specific pattern. So raw underscore input underscore data, and you have a date time format mentioned here, date, month, and year. So if there is a problem to extract only the date time and year, I mean, how do you do that? So let's say we write one function called string ops, and we are passing one variable as a string. So and this is our one of the Python functions. So it does not require to mention the return type here explicitly. So if you put a return type, so it will automatically return to your program. And see, we have not even mentioned the data type as a string here, so it will automatically sense according to your data pattern. So here, I mean, on the received string, we'd like to, I mean, find out the underscore first. So this will give you the position, the first position of the underscore, right? So the first position of the underscore is this one. It will be 0, 1, 2, 3. Okay, and literally we can capture the rest of the string. Okay, from here to the length of the string. And again, for this part of the string, if we can find the first underscore, then we can take away this portion, and at the last we'll be getting our date time. So this is the logic, I mean, that is implemented here. So as we know, the position of the first underscore, it is captured in first num variable, and from there up to length of the string, we can gradually go and find the string, right? So this is one method. Maybe it's not an efficient one. So I mean, Python is giving one more options to do it, I mean, very easily. Let's say if we use the string.rfind, the rfind will give you the highest position of the character that we are looking into the string. So that means it can directly give you this one. Okay, so that we just can put do a substring operation. It's very simple. If you give the string name and the position name and the length of the string, so we can just get this one, right? So I mean, we'll be getting similar kind of output from there. So let us see the output.
Paula sir,
Yeah.
if possible to increase the font size.
Mm, one second. Search for it. I mean, it's better, I think. Huh?
Yes, yes, yeah, and now it's good.
Yes. Thank you. So I mean, sorry, maybe you are not, I mean, getting rightly. So I mean, the way we are finding the last portion, I mean, datetime portion in a string. So because when you do some kind of program, the string operation is very, I mean, common that we need to do in regular work. So just why I'm just explaining the pickupping the specific location of some string and extracting the portion they would like to take. So this is one, maybe one inefficient method to do that. We can write in a recursive code to do that. But Python is giving you one more feature which will directly pointing the highest position of the uh, substring that you are looking into a string. So based on that, you'd be able to capture that. So I mean, if we want to run it now, okay. So in our function method, it is giving also the same output, but using our find method, so it's giving the output with, I mean, lesser effort. So whenever you do some kind of operation, I mean, just check that if there is something already done in the community, so that you can use that, I mean, libraries or packages to make sure that, I mean, the operation is efficient. So this is, I mean, common practice for any of the programming languages. And so we understand, I mean, Python is having string, integer, float. This is very basic, and we do some operations on string as well. Just let's observe one of the parameters like list. Python list is kind of array, but the beauty of the Python list is can contain different data types. So in particular Java or C array, if you remember, we need to define the type of an array. But in list, you can put a different type of, I mean, we can write like this also in our program. And you can access a particular list item like this. I'm mentioning the position. The position start and you can extract number of elements also like this from 2 to 5. You can update the list like this, and you can print list also. So I mean, we can, I mean, have a check. Okay, so initially we are, I'm printing the item number 4, 0, 1, 2, 3, 4, and that should be 5, and that is our output. And if we need to extract position 3rd to position 5th, so 0, 1, 2, 3, 3, 4, 5. So it will give you 4, 5 only. And if you want to update these two, that means 0, 1, 2, this should be updated. So instead of 3, it will be 400, and that's what is reflecting. And if you want to print the whole list, you just put the list into the print statement. So you can see, I mean, it can contain both integers as well as a character, right? So that is about list. And what is about tuple? So tuple is another data type. So it's almost similar like Python, but fundamental difference between tuple and list is the tuple cannot be updated. So it's immutable like RDD in Spark. So this statement is not valid for tuple, but you can create one tuple with multiple data types if you need for any of your operations. So I'm skipping this one because it's very similar. And the most important one, which we'll be discussing now, is the Python dictionary. So it's very, I mean, efficient and to deal key value pairs because the word count algorithm. So Python dictionary is like hashing things. So you can also use the word count algorithms, word count problem to solve the problem. You can use Python dictionary. So dictionary is kind of key and key value pair. It's like this. So let's say we have a predefined dictionary like this, or you can like define your own dictionary, like you want to define like this. It should be start with second bracket. Okay. So this one will be giving an interpreter that A is a Python dictionary, right? So if it is not initiated or with some variable. So let's say we have one dictionary like this. We can print a specific value of a key like this, and we can print all the keys together. Let's say 1, 3, 4. We can word 1, word 2, word 4, and we can also print the values separately, like using dictionary keys and values. Now, I mean, coming to our word count problem. That let's say we have a string called "I want to learn Python," but I'm afraid of Python. If it is snake, right? So I mean, if we want to count the word of this string, how can we utilize the dictionary, right? So word count dot split. Split is a function of the string data type. What do I mean? It will give you an array of words by space. So then you can run your operation. Let's say we define count as a dictionary, as I told you earlier, and for each word into the array of words, if word is available in the dictionary, right, then you just increase the value of that particular word. So in the dictionary, if that word exists, that will be working as a key, and we are getting that specific value. Otherwise, we are giving a value of that particular key 1 because we haven't find that. So just give a 1. So if this loop ends, then we'll be getting where we'll be. I mean, how many eyes, ones, all the words number, right? So this is, I mean, if you want to do this. So now, I mean, if in the so initially we are defining our own dictionary, and it's pre-initialized, and then we have received an array of string from our string using the words dot split. This is the state, right? And when all the counts are here, so I has been counted as 2 because I is mentioned 2 times. So this is the way, I mean, we need to do the word count programming in Python. In using dictionary is very easy, but if you want to take any other type bigger than this, okay? So you will be getting some kind of uh, uh, similar to this problem using only Python. No need to use any Spark or big data. So you just need to create one program so that it can read multiple files and count the words. Okay, so that will be communicated to you separately. So this is the way, I mean, in traditional way, how we can use word count using Python dictionary. And now coming back to the some mathematical things, right? Let us put our exit is here. So let's say we assign one integer to A and we'd like to take B, and we need to take out the division result, but which we are not expecting the floating bill, right? So then you need to use 2 slash operators here. If you give 1, then you will receive one floating, I mean, output. It might be something like 3.5 or 2.5. And if you need to construct the if else, it's like this. So if the logical operator is like this, if you want to equal some value, and then you need to put one colon. And one of the important fact of Python is whenever you are mentioning your code block, if you already notice, I mean, we haven't provided any brackets to understand, I mean, what is the area of the code under this if expression, right? So Python will detect this automatically based on your I mean, you see, I mean, here we have provided some tab space, so you can give space, tab, whatever. If you use an ID, it will automatically suggest the similar kind of spaces so that we can identify the exact block. But within the program, if you use tab as ident, and then if you use space in somewhere else, it might give you error. So I mean, if I put the print statement ahead of here, so it's not part of, I mean, this if block. So if I need to move back, then Python will understand if I find p equal to 1, I have to execute this one. This is the way it understands, I mean, the whole flow of the program without having any brackets within it. And then we can define elif, else if, and then else. This is not a conceptual thing, just to explain you, I mean, how, I mean, we are building the else if. In Python, as far I know, it doesn't support the case because it does not require. We can utilize case or switch statement using if else if. And if you want to write a simple, I mean, if statement, that is also supported. Yet we can run this and see, I mean, how it works. So this is the output. I mean, if we divide like this, so the output will be definitely 3 into 4. 3 times 4 equal to 12. So the B will be getting 4 definitely, and the right output is the 4, right? Because we do double slash. I mean, we're expecting one integer, full integer. So that will be 4, and that will be cast here. Okay, so this is about, I mean, how we can construct if or else if. And we can also define arrays in Python like this, and you can update like this, and also access in similar way that we have in case of the list data type operations is similar like that. For the for loop, so Python is using in. So if you use for j in a, I mean a is an array, so you'll be able to access the j and print out. So if you need to do some kind of logic, you can do within this section. So I just the for loop is printing all these values within a, which has been defined from 1 to 6, and we updated the fourth element to 10. So that's why it's printing 10 as well. For while loop is just so let's say we have a decimal number and we'd like to convert it to binary. So till the decimal number, so we know, I mean, how we can make it to binary, right? This is a simple program. So we are finding the mod. So mod operation is similar like C and other languages. And here, as we explained, if you want to bring the decimal number out of a division, so we need to use double slash so that we can get the number and continuously iterate up to until it's more than 0. So, and if we are getting the mod into a resulting string, that mod resulting string will be our binaries, right? So if you see the while statement is also same. You need to give the colon, you can put your condition, logical condition, and under that same indentation you can put the logics that you would like to run under while. So it will run for that, and your resulting string is the mod concatenation. So I'm building that string. So we have provided, I mean, 7, and the resulting is 111. So if we provide 78, hope it will provide you the expected. So this is the binary of 78, right? So this is just, I mean, how we need to construct the while loop. And now coming to the file operation, I mean, how we need to do the. So in earlier exercise, we see in the trips.csv, we have some trips taken or given by the drivers or passengers. So we'd like to access that. So the file can be opened in multiple ways. So when we provide R, right, that means read only. If we provide R plus, it is read and write. If we provide W, that is only write. If we provide WR, it's also write and read. If we provide RB here, like this, it will be, the operation will be like binary read or binary write, WB. So using open, we can open a file and get the file object. And if you want to go until the last line, so just put a while through. Using this one, we are reading each line until it's not blank. We will continue, otherwise we will break here. So I am printing the line while I'm going through. And as this is a input-output operation, so I'd like to bring the exception handling portion as well, so your program is not breaking while you are doing IO operation. So the standard way to put the try catch for any other language. So here try and accept. If there is an IO, we can catch it. Otherwise, definitely we should be going through the program. So this is a simple file read. You can do the write also by seeing the manual. So here is the file. If you remember that trip ID trips, there is a CSV file. So it's reading all the lines just one by one and printing in the output. As we have received the file without any error and permission things, and that's why there is no IO error occurred. And whenever we do file operation, please remember to close the file to save your memory. It's best practice. And so we use lambda function in Spark to load our files in RDD and do some kind of map and flat map operation. So, and that is a Python lambda function, right? So let's say we write one multi lambda function which will accept 2 arguments and which will give you the multiplication result of the 2 arguments. So multi is a lambda functions which we have defined in a very simple manner. So this is our lambda functions. Multi equal to lambda, it's accepting 2 arguments and it is just multiplying it, and it's ended with the semicolon. Okay. So if we call that function lambda function, so it will give you the output of the multiplication of 2 arguments. So this is the lambda functions that works in this way. So you can do many types of operations. Just if you want to run the line. So you see the multiplication result has been shown 300. So we are receiving the output in check lambda and printing out here. Okay. And now if you want to understand, the import functions, so we already imported time and other things. So we can also write our own Python packages and import in our program as we need. So for example, if we go into the findprime.py, so this is one Python. In this findprime.py, we have defined one function called prime identify, and it is shown that it's accepting one parameter or arguments, and it is returning some integer value, right? So this one is not something else. It's just calculating or checking whether a number is prime or not. So in the primary condition, it's putting the check is 1. That means the 1 is a primary, or if it's 0, then it's not a prime number. And if it is checking some base condition, so we know that prime number is started with 2. So before 2, 0 to some other numbers should be 0. It's not prime. If it is 2, definitely it's a prime. If it is more than 2, the efficient method is to do the square root of the given number and try to divide from 2 to that square root until if there is any, it's divisible, I mean, by any of the numbers start from 2 to that square root number. So if it is divisible by that, then we can break and it's not a prime number. So this is a simple logic, right? So that's not, I mean, we are going to run here. So if you go to the basic, our main program, so you see, I mean, we are requesting an output from the user. That's why you use input. In the Python 2, I mean, we need to write raw underscore input. If you write here, as we are compiling with treat or something, it will give you error that I don't understand raw underscore input. So we are expecting a input from the, I mean, user terminal, and after that we are passing that number. By converting the number into integer, we are passing into the functions. But before that, we need to export the find prime. So we have imported that, import find prime, and whenever some import statement is used in your program, that you will see in this ID as, I mean, if your theme is like me, you will seen as blue, right? Otherwise it will be like this one. It's meaning this matplotlib is not being used here. That's why it's like this. So we have imported find prime, and now we can access the functions and pass the arguments and get the result. And if it is 1, then it's a prime. It's not, then it's not prime, right? That's a simple program. So if we run that one, I mean, so see if it's requesting one input. Let's say if we give 57, so it's not a prime. I don't know if it's correct or not, but it's saying it's not a prime. So let us keep one prime number. So 11 is a prime number. So that's what I mean. We can create our own Python and we can access the functions written over there like any external. So we'll see, I mean, how we can use any external packages, right? So pandas is one of the popular libraries for data science. So in pandas, I mean, we can do similar kind of operation which we have done in Apache Spark data frame. So let's say using Panda, now what we are doing, we are loading the CSV files of trif.csv, okay, and we can print it, group by it with some column and show it, and even we can count how many rows are there for a particular column. So we can do almost all type of operations that we have done in Apache Spark data frame, and this is also called a data frame. But the name is Panda data frame. So Panda is an external package which we need to, I mean, install it. So for that, I mean, if you go to your command line, we have to go to the command line, tools window. If we go the terminal, right? So you will see a terminal in your virtual environment. So if I give pip in pandas, then it will be searching. So it's saying that the requirement is satisfied. I mean, it's already been installed. The Panda is already installed. But if you want to install, let's say we want to deal with some library to access MySQL, right? So you see, I mean, the Python is taking the MySQL, and to install the MySQL, if it is required, I mean, any kind of dependencies, I mean, it will check that and then it will try to install that. For example, in pandas, whenever you install, it requires NumPy package, so it will install both panda and NumPy package together. So now, I mean, this operation I would like to do in a Python shell so that it's more interactive. Let's open one Python shell here. So it's a separate shell, interactive shell, pandas. Let's import pandas in our statement, and then we would like to load our trips.csv that has been used earlier, right? So it has been loaded in Panda data frame. You see, I mean, the data frame is printing the all the details here, right? Trip ID, destination, pickup time, trip time, cost, driver ID, and passenger ID. So if you'd like to, if you see the passenger ID, driver ID, so here we can see, I mean, 1026 driver ID has given, I mean, 2 trips. So if you want to run one analysis here, I mean, driver ID wise, if you want to group by, then you see that this driver has given two trips. So that's why the other columns are showing true. And for a particular column, if you want to count how many rows are there, so you can also do that. There's 4, I mean, so we have 4 rows for trip ID 2001, 2, 3, so that can be also counted. So there are many other operations you can check using Panda package details, but it's, and also using Panda SQL package installed, you can also run the SQLs on top of any data frame which has been loaded in your memory. Okay, but the fundamental difference is it's not being used in distributed fashion like Apache Spark. It will be using your own machine where you are running this one. But yes, it will be, there is some efficiency which can, I mean, utilize your multiple cores that has been allocated in your single machine. That can be done, but it will be done in your single machine. So even, I mean, we can plot the data graphically as well in Python. So that's why, I mean, we have installed one of the packages called matplotlib. So using that, I mean, we be able to do some kind of analysis in graphical format as well. For example, if you can import that in our Python shell now. So we have imported as PLT. So this PLT object will be able to, I mean, show us some data in a graphical manner. So let's say this COVID-19 data set we are loading in a Panda data frame. So let us load it here. And if you want to show the data, I mean, date-wise, how many cases per day, if you want to load it, and we want to see a line graph, and the color will be red, so we can do right. So this is the one, I mean, date-wise, it is showing the cases. And if we see our data file, that will be, I mean, more helpful for you. So I'm opening in Node++. So it is showing a date-wise death case country areas that we have loaded earlier. So from there, I mean, date-wise, we are trying to show one graph. And also, I mean, country-wise, if you need to analyze some data in a bar chart, right? That will be shown like this. Okay. So these are some external libraries. I mean, so you can, if you come across installing some packages, you use pip, and you can install and import that and use like this. These are just some example. And as I told you, I mean, if you need to capture how much time your Python program. So now again we are taking the time and differentiating our start and end and identifying how much time, I mean, it took to run the program, right? So now if we want to run it again for overall, right? So this is our prime number program. So our program took around 4 seconds, 4.6 seconds, and that's why, I mean, so the graphical, I mean, the graph that we have drawn, right? That is not run because it requires some interactive mode to show you, and you can also save in PNG format. So this is about, I mean, how, I mean, to work with Python in a very basic format. So you can start writing your code and passing the arguments, declaring the data types that you need, and do some string operation, installing packages that you would need, defining functions, importing functions that you have written in your Python script or from external package, uh, running Python not from the IDE but actually from outside IDE in your actual production or development environment using Python space your own script. And you can also access, I mean, the arguments that you have passed. So I mean, that's all, I mean, from Python side. So I mean, before moving to the next session, which is based on the Unix and using shell scripting, I would like to, I mean, ask to dear participants, do you have any query on Python? So if you don't have any query, then I mean, we can go to the Unix shell scripting session, because for a single 2-hour session covering Python and shell scripting, it's a bit difficult, but I mean, at least we can cover what we need in coming days, and after that we can take the question. So let us move to, I mean, Unix shell scripting. So I mean, the way we understand how it works, the logical operations, printing, taking output, everything in Python. So we are also going to do similar kind of things and learn for shell scripting. So it might be confusing you, but keep try to notice that we are trying to do it for now the Unix shell scripting, not for Python. So it would be a bit, I mean, similar, but not, I mean, fully similar like this. So we know, right, I mean, what is operating system. So I would not like to explain much, but why we need operating system? Because the operating system is giving the user flexibility to work with computer hardware in a convenient way, and developer like us, we don't need to think about in which platform really my application is running. So most of the case, the operating system will be dealing with the hardware. So we are only thinking about the operating system and making our programs, and rest of the things, I mean, managing the resources of a hardware and starting running things parallelly, managing memories, most of the things, I mean, operating system do take care. So it's a layer for us to interact with hardware in which actually the programs and codes are running and giving out output in output devices and taking input as well. So we know there are many other operating systems like Mac, Android, Linux, and Windows. And we are user basically interacting with applications. It's generally coming to operating system and executed and back to again user from the hardware. So the Unix story, I mean, it has been developed in Bell Labs of AT&T, including version 7, system 3 and 5. The most widespread version is BSD version 4.2 and 1, and it's been developed in University of California. Nowadays, the most popular Unix free open source kernel is definitely the Linux kernel. And the history of Linux began basically in 1991. The Finnish student Linux Torbendas. So he created the open source Linux kernel. Since then, this is the most, most used Linux kernel, which has been adopted by many companies, and there is a large amount of communities who has been continuously developing and improving the Linux kernel. And it has two versions. One is, the open source community edition is CentOS, let's say, which we are using. And there is one enterprise version which we generally say Red Hat Linux. And based on the Linux kernel, I mean, there are many other distributions been built up like Ubuntu, SUSE Linux, and all. So just to understand the basic concepts, whenever we log in into a Unix machine using username and password, we landed into a shell. We need a shell, and this shell is interacting basically with whenever we are running a command. So we are within the command. The command has been made from multiple system calls, and that will be interacting with hardware, right? So the core system calls that is given by our kernel, and that will be communicating with hardware directly. And on top of that, we are building different kind of applications like Python applications or many other utilities. So the shell is the media between user and the operating system hardware, which will be giving the access to the kernels and computer hardwares. So you'll be knowing, how many types of shell and all details today. So kernel controls basically the computer hardware. When you log in, it is the kernel that runs init and gt to check if you are authorized to log in, and you need to put the correct password, right? And it keeps track of various programs that you are running, allocate resources for you, stopping and maintaining the time sharing. And it's also assign you storage and the shell programs. So there are many types of shells available. The popular shells are Bourne shell, Bash shell, C shell, and Corn shell. And many of the Linux distributions may not have all the shells available by default. Let's say you may not get Corn shell in your CentOS, but you definitely will get Bourne, Bash, and C shell. And by default, due to flexibility and all, we use Bash shell. So in reality, kernel, as I said earlier, also is a group of system calls. When a command is generated, for example, a file read operation using a cat command, so it will create, some system call write open. So first, before reading a file, you have to open the file, which will need to access the file from the storage, and then the read system call will start reading and giving you the bytes back into the cat program that you have run. So those systems calls are already implemented in kernel. So what is a file? A file is a very important entity in any operating system. So file is basically a series of bytes. So file can be a part of directory or subdirectory, but a file is definitely having one inode number, and it contains all the metadata of files, and also the file contents are, and so metadata includes, I mean, the file names, the permissions, the owner's details, and the contents of the files also stored in the same storage. So if you're not too, you need to, I mean, find out the inode number of a file, which is unique, I mean, within the partition that you have kept the file. So you can, I mean, access the inode number like ls minus I file name, you will get the inode number. And this image is showing basically the soft link or hard link. So we can create, I mean, soft link, hard link of a file like Windows shortcut, right? So sometimes if the multiple files is referencing to same inode number, that is called hard link. But if we are referencing to one file in backend, I mean, it's going to the same inode. Then if we delete the mysoft link, basically my file.txt is still intact. So this is a shortcut. But if we delete the actually the inode number, then all the hard links related to it will be deleted. So this is just, I mean, soft link and hard link concepts. And one of the important portion of file system is the partition, right? Whenever we added a new ticks, so we need to make sure that whether we'll be doing some partition or not. If we do at least one partition, we need to assign file system. So if you see, I mean, the common output, the file system type is defined here, ext4. In CentOS, we will find xfs as the file system. Okay, so all these file system that we have, I mean, all the partition that we have created in our partition during CentOS installation, you will see all these are marked in etcfs step. And if you run the block dev command also, you will see, I mean, what is the base block size. For HDFS, what we found, it's 128 megabyte, but for a base operating system, it's generally 8192 bytes. So it's more or less than what we configured or know about HDFS block size. So in a file system, I mean, the first block, the first group consists, it's called super block, and second block is devoted to the inodes and the metadata of the file. The third block and ongoing will be storing your actual, I mean, data, which has been kept by the user. This is some basic Linux things. So why Linux, Unix is better? Most of the things are open source. So you need to, if you would like to understand some mechanism, you can go and study and also contribute. So it has been developed by many talented engineers around the world. So it's been secured, tightly secured, and it's perfect for programmer. We can do many customizations, free to use, better community support, and reliability is really high. So I mean, if you think about a large application like Google or Facebook, so it's running mostly on the Linux or Unix systems, or so big platforms like these are not running on the other operating system that we came to know, like Windows or Mac. So its reliability perspective is uncomparable. I mean, to run a big, I mean, server application. So Linux or Unix, these are the better and proven solution operating system. So basic Unix command like how to listing directories file, changing the directories, copying, moving, renaming. I mean, we have shared some uh, some commands list. I mean, you can go through those, so you will be habituated. I think all of you, as you have already set it up, your Spark and HDFS, or trying to set up, you already know all these basic things. Just how to kill a process. So it's all been included, whatever materials we have shared. You can just have a try. So today our main focus point is the shell script, right? So whatever command we can run, either using Python or using base, I mean command list available in the Unix, that we can club together uh, and run under a single file, and that's called, I mean, shell script. So let's say now using cat, we are saying to the shell that we would like to uh, give some input to simple.sh, and then so the direction of this should be reverse. I would correct that. And when you create your fast program and it's saying echo this one, so it's printing, and then it's printing one date. So this is a date command. We know we can get the date, and then you put Control D. In the simple.sh, you will have these two lines. And whenever you create one file, your file would not be having the execute permission by default. So to run that one, so you need to assign an execute permission to that script so that you can run like this. So if you run like this, you will get this is my first shell script, and the date will be printed. So this is a simple program. I mean, if you create the shell script and you put some commands within that, you can run at a time like this. But remember that in most of the Unix system, the Umax is set it right in like a way that when you create one file, by default it doesn't have any executor permission. So you can, so here we have given the user who have created this file, so we have given the access, I mean read execute permission to this script. So only user can run it, maybe other group or any other user cannot run it. So we'll be doing some kind of, I mean, basic operation like Python in shell script as well, and see, I mean, what are the building blocks and what is the powerful things that shell script have to make our life easy. So before going there, some key things that we'd like to highlight. I mean, if you define a variable, right, in shell script, uh, like Python, so you would be able to, if your variable name is variable, then you can access variable value with a $sign ahead of it. So there are three things available for interacting with operating system, right? One is input, output, and we might get a scenario to, I mean, find some error, right? So if we think about input is 0, so like the earlier statement, I was saying that if we like this cat and smaller and add or text, that means this cat statement is expecting some input. So its direction is expecting some input, and the input is basically identified as 0, output is 1, and error is 2. So just remember, for the time being, we'll do some exercise. And let's say if we are printing some line hello, and we'd like to paste it in a file add.txt, and if it is already exists, it will override it. And it's not, if we want to append it, we need to put 2 arrows and like this, and it will append this. So these are part of, I mean, moving output to a certain file. And if you'd like to, I mean, run one script and want to capture if something goes wrong, I mean, errors we want to cover with the output, then, I mean, this is the command, and we want to keep in the output file, but please give me the output as well as the error. So we need to like this way so that we can capture both output. We are saying one is output to give me the error as well along with the output. for my script that I want to run. And so, I mean, in the Shell script also you can give the arguments while running the script. So you can access nth number of your argument, like dollar and n value can be 0, 1, 2, 3, whatever parameter number you would like to access. And total number of positional parameter, let's say you have provided 10 arguments. So you want to know how many arguments the user have provided, that you can get with $hash. And you would like to run a command and you would like to grab that output in a separate variable, then you need to have this syntax like this. And we know, I mean, whenever we are interacting with Shell and we are setting up some Shell variables, like, as you remember, I mean, we are setting up Hadoop home to home Hadoop, right? So this is the variable name that we have provided and set it up in the bash rc, which is executed every time the Hadoop user logged in. And so that whenever it's initiated, it will, I mean, export this variable out, right? So that we can, whenever we will be using Hadoop home, that will be pointing to a specific directory. So we can store our own customized variable. And if we put into the bash rc, which is the initiator of any bash shell environment, so you can make that one and export this customized variable. But by default, there are many common variables which has been set it up from the Linux, which can be home. You can get your home like home Hadoop. Log name will be username, host name will be host name that you have given from which machine is running, and your whole path, whenever you are putting a command, it will traverse that this command is part of this directory, that directory. If it's not getting, then it will give you an error that I haven't find that command that you have run, and I have checked all of your path that you mentioned in your path variable. So if you run something and it's saying the system cannot find, maybe binary is already in your machine, you just need to keep the absolute part to Unix understand from where it has to run. In your own environmental variable that is required, I mean, in a common basis, you need to put export and the variable name, and definitely whenever you are assigning that, it should not like, I mean, this. So whenever you are accessing the variable, then you need to give the $sign. When you are assigning, don't give the $sign. And I would like to correct this one as well. It should be input, right? And you would like to, I mean, run a command in background. I mean, whenever you're in an interactive shell, you run a command, let's say it will run for an hour. So you need to, I mean, keep silent. Oh, okay, the command is running. But you can run the command in background. I mean, you can get your interactive shell back to you while you are working with other program. Your program will run, right? You just put commands space ampersand, then the system will give you an ID. Okay, I am running your job in background, because operating system can run multiple processes, right? And sharing the CPUs. So you can run other commands and working while your command is already running. And piping is one of the powerful things in Unix. So let's say we used to, I mean, find out number of CPUs, right? Let's say the process is dynamically create a directory for system operations. So you can go to the CPU info and try to grab the CPU core ID, and if you count that line, and you will see, I mean, how many CPUs. So what this pipe is doing, so it is getting one common output and passing that output as an input to the next common, so that, I mean, step by step we can take input from the previous common output and we can find out what we are basically asking, or we are trying to see. So all the positional arguments that you have provided to shell script that can be accessed to dollar and star at a time. So let's say I have given a positional parameter to a shell script 1, 2, 3, and we can get all the 1 to 3 arguments, and also the shell script name using this one. Exist status of last command is 12 number. So if you run a command, and you can check this one dollar and question mark, so it will give you whether the last command was successfully run or it has some error. So if you want to get the PID of your shell that you are currently on, so you just need to put double dollar sign, you will get the PID. So this one is extensively used generally whenever you are running a backend operation using a Unix schedule job and would like to capture those logs in a file, but the file name you would like to keep as unique. So the Unix, these PIDs at a time in an environment, this is an unique random number generated from the operating system. If you add your date time with PID, that will be definitely an unique number. And if you put in your file name, that the file name will be unique, and you should be able to create that file. So if you would like to define some quoting in your string operation, you can use single or double. But contrast to this one, comparing to Python support anything. Single, double, triple. Just whenever you're starting with single one, you have to terminate with a single one. Whenever you start with double, it's end with double. You cannot use both, but you can use either single or double in shell scripting. You want to keep some comment for within the code to explain to your colleagues or better management of your code. You can use hash in your coding. As I said, to set a variable within the program, you can set equal to something. But when you would like to access the variable data, you put $a. And coming to, before going to the practical session, you write one program, right? A simple program, which is giving you the date. You create one file, put date statement, and you give the execution permission. Now you would like to run the date statement, that shell that you have created very fast in a scheduling manner that you would like to run in every day. Let's say in 15th hour, 3 p.m. you would like to run every day that script, right? How to do that? So you need to check, cron tab -l, there is one command. So using that, you can see, how many schedule jobs you have currently now in your system under your user. So now if you would like to edit or add, you can give cron tab -e. You will get the panel and you can start type like this one. This script would like to run on 00, minute, 15 hour, and that's all. It will be running every. So using this one, this star, 3 star, you can convert, to any of these statement, so that you would like to run in a specific way. If you want to run, let's say, in a fast week of month, you can configure that. If you would like to run in specific day of a month, you can configure that by following this guideline. The first tuple is noting the minutes. The second one is the hour. The third one is your day of month, 1 to 31. And fourth one is mentioning the month of year. You can also specify every year it will run on April, something like that. And you can specify week number as well. Not week number, weekdays. I would like to run every Sunday or every Monday. You can configure like that. But you just need to, for week, you just need to remember that it's an international system. So we are starting with maybe Sunday, but generally in worldwide the week is starting on Monday. So based on that, I mean, you need to put the right value to map with the right day. Okay, so this is the scheduling part. So before going to the next one, I mean, I would like to log in into my system. Okay, something wrong with my system. So I lost my IP. Uh, 106. So I logged in my system. I am in Home Hadoop. Let me go to the development folder. Yes, I'm in. So do I need to, I mean, increase this font size as well, or it's fine? Thank you. So I have created already one shell script practice one, so that I can go through like the way we have went through in the Python. So here I also want to put the exit one, so that we can step by step run and see, I mean, how it works. So before going that, I mean, I would like to create one very simple, I mean, test1.sh. So this is my first script. Let's say this is my first script, right? And I would like to print the date string. This is the first, I mean, shell script that I want to create. So now, I mean, if you see the permission of this one that we have created, so this means it's a file, right? If it's directory, it will be denoted as D, right? And it is saying that this 3 section is for the user, next 3 section is for the groups the user belongs, and the next 3 section is for any other user in the system. So first one, as I said, is for file, and it has write, read, and oh god, it's not having the execute permission, that's why it's dash. And for the group, it has only read permission, write, execute is not there. For other, it has only got, I mean, read permission, write, and execute is not there. So I mean, if I want to run it now, test1.sh, and it's saying permission denied even for the same user. So I would like to give the user clear access of the execute permission. Okay, then if I run it, it is showing this is my first script and this is the date, right? Today. Okay. So this is the one I'd like to show. I mean, if you create your own shell script, please, I mean, make sure that you have the right permission. So the permission why it's not given with the execute is related to your UMAX value. Okay, so if your UX value is by default 0022, if it's different, then it might give you the different access permission whenever you're creating a file. Okay, so it depends what's the UMAX value that has been set in your Linux system, or you have customized it. If you customized it, if you create a file, then it might have the execute permission by default. Okay, it's based on the UMAX, but by default, whenever you install the CentOS and you haven't changed the UMAX value, whenever you create a new file, you don't have the execute permission. So now, I mean, let's go one by one and see what is the building block of shell scripts. So here, if you see, I mean, whenever the best practice is to define in which cell you are running, right? So we are running in green mesh. So that's why I have defined it. And I would like to say it's my first script, and I would like to capture the date common output into a variable, and you see how it has been done. So I have to give the case I can't remember this one, the sign name specifically. It's just under escape in your keyboard. So you can get the output of date to your capture output variable, and you can print it. Okay. Run it. I have put one argument here. So just skip the argument for the time being. Okay, so it is giving the output, right? But this one is not printing date directly. We have been receiving the output of the date into a variable, and we are trying to print that. Okay. But if you want to change the date format, the way it's printed, I want to see in a different format, right? And I don't want to see Saturday or all this stuff. I want to see in a number format. So I have changed the date like this, and I want to keep that formatting to a variable, and I want to access the variable data, and that's why I have put one and $sign in front of the variable name. So I'm deleting this one and or exit to the next one. So see, I have changed the date one, so it's 2020. It's the year, month, date, and time, hours, seconds. So whatever we have mentioned, it is keeping in this way. And you can assign variable like this. Let's say number equal to 1. Okay. But you don't need to define its integer float, it will sense it automatically. And this is the one that I would like to say that this is if you remember in our slide, the $hash, this is the number of arguments that we have passed while running the script. So if it is less than the 1, right, then it will say, give me the actual argument that we are expecting. In many of your shell script, when you start building the professional shell script, maybe you would require some argument to be passed while run. So you can control user without giving the right number of argument. You won't start processing. So you just initially check whether the given argument has been given to you or not. If not, you can give an error message saying that use this statement, otherwise I am exiting, right? So let's say this script is saying if my number of arguments is not at least more than 1, it should be at least 2 or more, then I will exit from this and start the other execution. Otherwise, I will print this one, how to execute this script, and I am exiting from here, right? So let's say okay, so I haven't put any argument. Okay, so before the if clause, whatever I have written, it's printing, and after that it's saying, please give me the argument. Okay. So if I give an argument, then it will continue to run the other statements. So you can have a control, and I am putting this standard shell syntax $hash to understand how many arguments the user supplied, right? So if you want to know what is the shell script name, then you can access $0 because that is the first argument that the user passed. And after that, basically your actual argument will come. The second argument can be accessed $1 and subsequently $2, 3, and n, right? So you can check that. So you see your first argument is the script that you have run, right? And the second one that we have provided 20, right? And if we have provided, let's say 20 more or 30, the third argument, so it would be 30, but we haven't defined it. So if we have defined, I mean, we can get the similar way. So let's check it. So if we have defined like this, right? So second, basically the third argument, and for you is this actually is the second argument. It has been accessed to, I mean $2, and we are getting output 30. I mean, ignore the print statement. It should be the second one. Okay. Okay, for time being. And as I said, I mean, there are many common shell variables, right? Let's say log name, home, Hadoop home that we have been setting up. So we can, I mean, also check the shell variables that have been inputted. So the log name is Hadoop. Even we can do it now, right? It's Hadoop. And then we can even evaluate one path, right? So all these paths have been set up. So if I run hi, right, it's saying common not found, because hi is not found in all the paths that we have defined, right? Even if we run shell practice.sh, right, this, you see common is not found, right? So, but if we define our home Hadoop development as part of the path, then we can get it, right? So let's say if we define path now. So first, get the path variable and define our own directory now itself, right? Now, if we print the path, we should get home Hadoop development is added, right? Now, if we run this shell script like this, which was not available, right? It is available now because the system is finding the shell practice from your path. So the path is very important. So now let us move back to our original one. So we understand how the shell variables are impacting us, and how the command being searched through the path variable and it's being run. So now let's just do some kind of, operation on pipeline, because we say the pipe is used to capture the output from a one command and push the output as an input to the next command, and subsequently, we can get the output, right? So let's say whenever you are creating a user, so it has been, putting an entry into your etc password.
Sir, no, sound is not clear.
Okay. Because I'm getting, huge generator sound. Just asking whether you are also getting the same noise.
But when you type in putty, then your sound is so much low.
Okay.
Okay.
Let me try from keeping the mic more closer. Okay. So whenever here we are creating a user, so there will be a new entry. You will find in etc password. So let's say this etc password is some kind of semi-structured file, and it has been delimited by colon, right? So think about a problem that we are given to find out all the user in the system, and we are asked to sort all the users in an ascending order, right? So how to do that? So in Unix is very simple. Let's say I printed out this one and put a 5, okay? And there is one command away. So I would like to parse this output. I know the separator is colon, and then I would like to print the first column, right? So see, very easily from the etc password, we can extract the first column, right? Using the away command, defining the separator column. Okay. So here we have all the users, but it's not, I mean, sorted, right? In any order, ascending or descending. So let us sort it out, right? So now it's sorted. If you see abert, ADM, bean is all system users, and we have created one user called Hadoop, right? It is been sorted. Now, if you would like to, I mean, take this output, let's say all users in system dot log file, right? So it will go into, so one file is created, and there in the file, all the users are in a sorted format in the list, right? And we can also see the file is created and dumped, right? So if you see, I mean, the beauty of the shell script that maybe if you need to do this kind of job using, I mean, Python or you C program or Java program, it takes a lot of time to parse that one and find out the names and sort it out. But using a single line, we would be able to do that, right? And even we can take output in a file, right? So using shell scripting, so there are many other commands like awk you will find in the internet source, and you can use those to make your life easier. Okay. So this is the concept or pipeline. I mean, using pipe, you can transfer the output of a command to the next level, so that and there is no limitation like this, so you can continuously giving out to the next command and try to grab the things that you would like to, I mean, take it out. Okay. So now going to the, I mean, while statement, because when we do logic build up, the while, for loop, I mean, these are the most important things that we need, right? So the positional parameter that we are sending through command line argument, right? So that can be set it up using set keyword, and let's say set is a while, right? So as I said, I mean, all the positional arguments can be printed by $star. So the value of positional argument can be printed like this, and you can go through each one of the positional argument using your while loop. So the $hash is giving the number of arguments, and if it is greater than 0, you can continuously loop it and print it. And using shift keyword, you can shift to the next. Okay, and it will print you the, this is all the positional parameter which has been kept using, I mean, a space separator. So you can print it. This is a while loop using this loop. Okay. I mean, let's check this one. So now we don't need to give dot slash. So dot, it means, I mean, it means the present directory, and slash meaning within the present directory we are running shell, right? But as we have added our directory, development directory in our path, we can directly run shell practice, give some arguments. So it will be running like this. Okay, I think we haven't. So there is one exit here. We have to remove that. Okay, so this is a while loop, and we have put it one echo, and it's giving blank space each time. Okay. So there is command. I mean, how can we print it, but without a new line, as we have shown in Python. So it can be done for and shell scripting also. Right? So this is, I mean, why you can build your own logic block, but it's not like Python. You need to give do and done. Within that, you need to code yourself. I mean, whatever operations or logics you need to put under white block. So it's not automatically created like the in Python using the space or tab that we have provided to understand Python, that what's the block of the while or if or else or function. So the same can be achieved in a for loop. So for I mean all the positional parameters. So it will be going through, but for loop you need to put the you need to access the I and print that one each time. So it will be like the similar output. And for example, you would like to access one of the directories files, and you want to access some specific type of files, let's say CSV files or TXT file or log file. You can write, I mean, for file in a specific directory. You can access or star, or you can like star dot CSV. You can do like this, and you can access those specific type of files, and you can do your own operations, right? So for time being, I mean, let's say, let's visit the for statement. So if you see, I mean, in home Hadoop, we have all these things, right? We have add.txt that has been printed, then w then development directories, and all these details have been pasted. So if you want to see only the CSV files, okay, because you may be interested on that only. So I mean, we can run that. So only one CSV file exists on home Hadoop list. I mean, we can verify that, right? So there is only one CSV file. So it is also getting the same output, right? And you can also, I mean, run for loop in shell script like C or Java. I mean, you can define the start and how long it will go and what is the increment that can be done in shell script. So it's like that. And this one is already tested, right? Changing the date time format and getting. And let's say in daily you are running one schedule script and it is giving logs every day in a date time format. And if you're running like that 1 year, in 1 year you will have maybe 365 files in your log directory, and you are, I mean, pulling up your partition, right? So you may be interested to keep one deletion script. Let's say I don't want to keep logs more than 15 days, 30 days. So that's a single statement in Unix. So you need to find a specific formatted file in your directory. Here, as per the command, what it will do, it will go to TMP and Spark events. We know in the Spark events, we are dumping all the logs that have been, I mean, whatever jobs you're running on Spark, is coming to Spark events directory in the temp Spark events. So all the files which has been accessed, I mean, 15 days back, we are taking all these files. Okay, M time is the last modified days since last 15 days. And then we are trying to delete those. Okay, recursively, if there is any directory also, it will delete. F means it will not ask user for any permission before deleting the file. So it is forcefully deleted. And coming back to the operation. So this is the way, I mean, we can maintain the retention of the logs so that my files system are not pulling up, I mean, with my logs, right? The logs may be related, may be required for last 15 days or 30 days, or any other way we can use that. So this is, I mean, about the practical session. So I mean, in the coming days, we'll be, I mean, using full of that or part of the functionality that, I mean, I described. So hope it's, I mean, helpful to you. So I will be sending all the scripts also, so that you can run and practice. And there will be 2 assignments given. One is based on only core Python. One is based on shell scripts. So please do practice. You will be receiving the assignment soon. So moving back to the slide. So we have, right, I mean, the cron tab. Let me show you. So for cron tab minus L, for Hadoop, there is no entry. So if you want to run our cron tab shell practice or essays, I mean, how we can achieve that. So if you want to run it in Shedule, so like, I mean, if you want to run it, say on after 3 minutes, so each hour it will run 1, 2, 3, 4, and display between Hadoop development. And it will give the output to temp.log, right? So you want to, if you want to, I mean, grab the error also, you can save like this. So now our script will be running, I mean, each hour 5th minute, okay, and it will be keeping our logs, I mean, the output for 1 and 2. If there is an error happen, that also will be captured in the temp output.log, right? So this is the way, I mean, we can put our script in the Shedule. And if you want to, I mean, keep any Python script, like let's say we have a Python program like Python, our test.py, we can write like that and save it and run it from the shell script as well. Okay. So this is the last one. I mean, the running Python within shell script. So as I showed you, I mean, you just need to put Python in the Python script name within the shell script. And for example, this one. So this is green bash, one shell script, name simple shell script Python. And it's better to reset your environment. I mean, your environment is defined in your user home directory .bashrc. So you can run once before executing any script. This is standard. And then I'm creating one variable where I'm taking the date, time, hour, minutes, second, everything in the variable. And I change my directory to temp. And I'm creating one log file. If you can notice, the log file name will be my Python script, and then there will be date, time, year, month, date, and .log, so that my log file is, I mean, uniquely created. And then we can even add the $sign so that we can take the shell PID as well to make the uniqueness of file more stronger. And I am running my favorite Python script, and I'm running one deletion script so that my old logs can be deleted. And I'm taking all the logs of my operation of Python script and the find command, including the output as well as the error, into the file that has been created within the script, right? So we can capture all the logs of the Python script as well as the logs if there is any logs out from the find command that we are capturing into the file name using the T command. T minus I means we are appending into the file. So if we run this script into a cron schedule, or we can run, I mean, on demand, whatever we prefer. So it will create all the logs coming out from the Python and find command, and which will be saved in a file name, which the file name is already created dynamically using this command, right? So this is the way, I mean, we can create our Python shell, and that can be part of one shell scripting, and that shell we can run in a schedule mode, right? So that's all, I mean, today's session. So I will be sending all the scripts that have been used here so that you can, I mean, install PyCharm, you can log in into your CentOS machine and practice both. And based on that, I hope you will be able to implement the assignment. So two assignments on will be there. One is on core Python, another is on mostly on shell scripting.
Palash,
And there are references also here, so you can go. Sorry.
there are some participants have some questions. They raised their hands. Can you please give them some time if I allow them to ask?
Yeah, because I have already completed. So this is the question and answer session. Yeah.
Okay. I allowed Khan MD Obaidullah and Moinul Islam. Please, you can talk.
Hello.
Hello, Moinul Islam. Please unmute yourself and talk if you have any questions. I can also see some other people. I admit all of them.
Okay.
Yeah.
Hello.
Joy, please.
I have a question. The last class we learned how to make the RDD
Okay.
using the parallelize, and we check that the it is working over the different clusters. Now my question is, how can we read a CSV file, and how we can train a model that will train over the clusters.
So I am not clear about your question. Sorry. I mean, if it's Mr. Joy.
Basically, I'm want to say, how can we train a model using the parallelized fashion? Machine learning model in parallelized fashion. Hello. Hello.
Yeah.
How can I actually train a machine learning model using different clusters? My question is, how can I read a CSV file, and from this data I can train a machine learning model using the parallelized fashion?
Yeah, Joy. So I mean, machine learning is not part of our course. So I mean, I would like you to. I mean, I'm advising you to just go through the Spark and leave. I mean, the documentation to do that.
Okay.
So I mean, any dear participant, do you have any more questions? I mean,
someone asked in chat.
Okay, let me.
Will there any more test exam be taken?
Yeah, of course. So there will be 2 assignments after the class, and then there will be 1 more quiz, and finally there will be 1 final exam. I mean, final assignment exam. So 3 assignment, 1 quiz.
Okay, if no other question, we can conclude the session today.
Sir, one thing,
Assalamu alaikum, sir.
Yeah.
yes, for Bangladeshi participants, if anyone ask answer in Bangla, he can use Bangla because our instructor is Bangladeshi. He understood Bangla and he answered in English.
Yeah.
So anyone may have questions, but uh, he can use Bangla. So participants, if you have any questions.
Assalamu alaikum, sir.
Assalam. কেমন
স্যার আমি বাংলায় বলতেছি, আমি নাজমুল হাসান।
অবশ্যই
স্যার আপনি স্যার পুটিতে কিভাবে স্যার চেঞ্জ করতেছেন ওই ইয়াটা? আপনার দেখতেছি ডেভেলপমেন্ট এরিয়াতে আপনার ইয়াটা স্ক্রিপ্টে দেখতে পাচ্ছি, আবার আপনি রান করতেছেন একটা ইয়াতে, ওইটা স্যার আমি একটু ধরতে পারিনি স্যার, আপনি যদি কষ্ট করে একটু দেখাতেন প্লিজ।
আচ্ছা আমি দেখি কোনটা আপনি কোশ্চেনটা অবশ্যই আমি পুরোপুরি বুঝতে পারিনি
স্যার আমি দেখছি আপনার স্ক্রিপ্টটা, আমি দেখছি আপনার পুটিতে চলতেছে, মানে এক পাশে ইয়াতে স্ক্রিপ্ট আপনার যেটা রান করতেছেন, আবার রানিং ইয়াটা আপনি রান করতেছেন, মানে দুইটা এনভায়রনমেন্ট দেখতে পাচ্ছি, কিন্তু ধরতে পারিনি স্যার এটা।
So I mean I am logging to the putty again.
জি স্যার।
Okay, so my network is interrupted. Maybe some problem. Okay. We try again. Yeah, so I am having some difficulty because I am joining from hotspot. I mean, what is the question?
স্যার আমার প্রশ্ন হচ্ছে, আমি দেখলাম যে না আপনার স্ক্রিপ্ট যেটা থেকে আপনি রান করছেন কমান্ড গুলা, আপনার স্ক্রিপ্ট গুলো একটা ইয়াতে দেখছি, আবার কমান্ড গুলো আলাদা রান করতেছেন, এটা কি একই পুটিতে মানে একই সংযোগের সাথে সেম পুটিতে কি বারবার করতেছেন, নাকি মানে আপনি দুইটা পুটি রাখছেন, মানে সেম পুটিতে আলাদা ইয়া করতেছেন? আমি বুঝি না জিনিসটা স্যার।
Same. So I am using one single putty session connecting to my one single send to SPM, and I am logged in using Hadoop user. So in the Hadoop user development directory, I keep my script and I was editing my script and showing and running from there. So no other terminal is used.
আপনি কি আপনার স্যার স্ক্রিপ্ট গুলো কি মানে মানে কপি করতে, মানে কপি কিভাবে করতেছেন স্যার? আমি সেটা বুঝি না। আপনি স্ক্রিপ্ট গুলো দেখতেছি পুরা, আবার মানে কোড গুলো আলাদা দেখতেছি স্যার।
No, so I have created, I mean, script itself in the, I mean, VM. So it's not that script is made in my Windows machine and I have to transfer using FTP or SFTP. That's not the thing. So I have itself created the file in the VM box. I mean, sent to us.
Yes, sir.
I mean, still confusion. So you can create, right, beam abc.sh and you can write. And this is the way I'm writing. I'm not creating or writing something in my Windows machine in Notepad Plus or any other editor, and I'm running it. No, that's not the thing.
Okay.
So if you log in and you beam me, and you will get all this. I mean, indication. If it's shell script, then that will give you automatically some coloring options. I mean, maybe you get confused with that coloring options.
Ji, sir.
I think Polash, he may also experience some issues during switching from VM and the Windows machine.
Ji sir, এটা নিয়ে একটু সমস্যা।
Okay.
Yeah, you can use some shortcut so that you can swap between Windows machine and your virtual machine. Okay, Polash.
স্যার যদি কষ্ট করে একবার বলতেন ওই ইয়াটা এই সফট লিঙ্ক আর হার্ড লিঙ্কটা মানে কিভাবে নোটগুলা।
Hello.
জি স্যার।
Any other question?
স্যার আরেকটা কোশ্চেন হচ্ছে সফট লিঙ্ক আর হার্ড লিঙ্কের ইয়াটা বুঝি না, একটু কষ্ট করে যদি স্যার আবার বলতেন।
Soft link is basically, I mean, so let's say you create one. So there are one command named ln, right? So you can go in the Unisyntax CentOS machine and create soft link and hard link using ln command. So if you give ln -s, that will create your soft link. So let's say you create one file referencing to one of your original file. So add.txt your original file, and you create one soft link or that add.txt named let's say b.txt. So if you delete, I mean b.txt, your add.txt will be kept as it is, right? That is your soft link.
জি স্যার।
But if you do hard link, let's say either of your file, if you delete, both of your file will be, I mean, deleted because it's hard link and pointing to the same inode.
বুঝছি স্যার, থ্যাংক ইউ স্যার।